Hi everyone, I'm Miss Vinise and welcome to another Preschoolers Explore STEM program. Do you guys remember what STEM stands for? Well, let's refresh. The S in STEM stands for science. The T in STEM is for technology. The E in STEM is for engineering, and the M is for mathematics. So we've got science, technology, engineering, and mathematics. Today, I wonder which one we're going to focus on. Let's see. We're going to focus on S for science. And in fact, we're going to discuss how scientists study the world around them using a process called, drumroll please, the scientific method. The scientific method tests a hypothesis, which is an educated guess based on the information we already have or information that we look up, maybe in books from the library. And today we're going to use our STEM kits to make a hypothesis, which is a guess, and then test it out to see if the guess that we had was correct. It's not about being right or wrong. It's all about learning something new. So even if your guess or hypothesis doesn't come out exactly how you had guessed it, we still are learning stuff all about the world around us, which is super exciting. And the scientific method I'm going to focus on today is really kind of pared down. There is so much you can explore with the scientific method. And there's lots and lots and lots of intricate steps, but I'm going to focus on 6 basic steps today, just to show you guys the thought process on how the scientific world discovers new things. But let's go get our kits. I'll be right back. All right, I got my STEM kit from the Pittsburgh Community Library. If you haven't picked yours up yet, come to the children's room and ask at the reference desk. That's where we're going to keep them. This month's STEM kit should have inside it a set of instructions, as usual, a test chart, a can of seltzer water, and your can might look a little bit different. I've got a few different types of seltzer water. 2 clear plastic cups. And in this bag, we've got all of our little test subjects. So there should be a box of raisins, a little container of lentils, which we'll just call beans for this experiment, and some pasta noodles. And these pasta noodles are shaped like tiny little seashells. You're also going to need a few things from home to do this experiment. So go ahead and grab yourself a spoon, or in my case, I found a fork, and something to write with. One of these cups is going to be filled with just regular tap water, which means the water that comes from your sink. So go ahead and fill one of these cups right up to here with your water. I'm going to go do that right now. I'll be right back. So I filled one of my clear glasses with water from the sink. I'm going to set it aside. And it looks like I have everything set for my experiment, except for one really key piece of information. What is the scientific method, and how are we going to use it today? So The scientific method I'm going to describe to you guys today is broken down to 6 simplified steps. And the first step is make an observation. What does that mean? Well, making an observation is looking around you and seeing what you see, or feeling things around you and feeling what you feel. So, for example, I'm going to observe that this liquid inside the cup is wet and it's a little bit cold. That's an observation. I'm going to observe that this box of raisins is kind of a dark purple. You can make observations using just your ears, hearing, seeing with your eyes, feeling, tasting, or you can make observations using tools like thermometers and lasers, lights. Scientists have tons of tools that they use to make observations. So the next step after we look around the world is we're going to ask some questions. So why is the water wet? Why is the water cold? Why does something look this way? Why is the sky blue? Why is grass green? Why does that sound so loud? Why does it sound so quiet? Why do certain things act a certain way? And what I mean by that is, why does wood catch on fire and burn away? Questions like that. So we made an observation. That was our step 1. And our step 2 is asking questions. And part of asking questions in the scientific method is seeing if you can just find out the answers by looking them up, which we call research. And you can do that research on a computer, or even better idea, you can do that research right here at the Pittsford Community Library. We have tons and tons of books. So if you do have questions like, why is thunder so loud? Or why is the sky blue? Do fish drink water? All of those questions can be answered by coming to the library and looking them up in a book. Or you could just ask me, your friendly local librarian. The third step is, this one's the tricky one. After we make observations and ask questions, we're going to make some guesses, which scientists call a hypothesis. So make guesses on why something looks the way it does, or sounds the way it sounds, or acts the way it acts. So we try to make guesses based on the information we've learned through books, or by looking it up online, or asking somebody who might already know the information. But in case you don't know, you can go ahead and try to make a guess of how this is going to work. So I have an idea. Why don't you guess what will happen if I take my 2 hands and put them together really quickly? Do you think I'm going to make a fireball with my hands? Do you think that they're going to make some pretty music? Are they going to sound like a cow? Or maybe they'll sound like a loud clap. Let's see. You guys go ahead and make a guess, and we'll see what happens. It's a clapping noise. So, making an observation is step 1. Asking questions and researching is step 2. Making a guess is step 3. Now step 4 is the fun part. Conducting your experiment, or testing your guess, or testing your hypothesis. So we're going to use tools to explore the what and why to see if our guess is correct. Step 5 is we're going to record and analyze the results, which means as we're testing out our guess with our experiment, we're going to go ahead and write notes. And in step 5, we're going to look at our notes and try to figure out what that experiment taught us. And then step 6 is you report your results. So you get to share with somebody the information that you gained by doing your experiment and whether or not your guess was right or if it turned out not to be true after all. So that's the basic 6 steps that we're going to use today for our science experiment. And this is a scientific method. I'm going to put up a slide right now to show you step by step. All right, do we think we have a little bit of a handle on the scientific method? Well, even if you don't, we're going to go ahead and use these cards in each step of our experiment to refresh us on each step of the scientific method. And the first step is make an observation. So for our experiment, what we're going to observe is first that glass of water that we got just from the sink. We're going to take another clear cup and we're going to put in seltzer water. What is seltzer water? It's water that is carbonated, meaning that there is little bubbles added to it. And we use carbonated water to make things like soda and other fun fizzy drinks. Let's make some observations about our water. Let's see. What is the difference between plain water and the seltzer water? Well, first off, the seltzer water, it's pretty bubbly. In fact, I think I'll call it bubbly water. So the bubbly water has lots of little bubbles. Plain water, no bubbles. Are they different colors? Nope, they're both clear. And they weigh both around the same weight, considering that I filled them about the same. Now let's look at our other test items, the pasta. So I'm going to grab out a little bit of pasta. Ooh, they are hard and very light. These are some observations I am making. The beans. The beans are also very, very light, not very heavy at all. They seem a little bit softer than the pasta. So if I squeeze the pasta in one hand and squeeze the bean in the other, this feels a little bit harder. And last, we have raisins for our test subject. Oh, well, first off, they're sticky, where the other items don't feel as sticky. And they are also very light. Ooh, they're very sticky. And these are very soft. So if I can actually squish them. That's how soft they are. So the observations I made are seltzer water is different from regular water because of bubbles. Pasta is hard and light. Beans are very, very, very smooth, also very light. Grapes are, well, the raisins are very sticky and light and wrinkly. So remember in the very beginning of this video when we went through all of the objects in our kit, there was a test sheet. We're going to write down some observations that we made on our test sheet about the raisins, the beans, and the pasta. And this first square on your test sheet, which is red, says, is it smooth or wrinkled? So wrinkly means that it's got little creases and curves in it. And on our test sheet, it says, circle the items that have wrinkles in it. Were the beans wrinkly at all? I don't think so. Did the raisins have lots of wrinkles? Yeah, raisins are very wrinkly. Let me get my marker out and circle the raisins. And the pasta, I think, has a little bit of wrinkles in it. It's hard, so they don't have soft wrinkles like the raisins, but it feels wrinkly. So I'll circle the pasta too. So this is us making observations. So my test chart looks like raisins and pasta have wrinkles and beans do not. Very, very smooth. So on our step 2 is we're going to ask a question. And our question was if it's wrinkly or smooth. But my other question is, does the wrinkles or the smoothness of the raisins, pasta, and beans make a difference in how it's going to float or dance in our water? I don't know. I guess we're going to have to test it out. But before we test it out, we have to move on to step 3, which is make a hypothesis. To make this experiment a little bit less crazy, we're going to take our glass of just plain sink water and put it over here. And we're going to focus just on the bubbly water. Our guess is, will the wrinkly items like the pasta and the raisins move around or dance in our bubbly water, or will the flat beans move or dance around in the water? Or maybe none of them will move or dance around in the water. I don't know. So in our blue section is our hypothesis or guess section. It says circle the items that you think will dance in the bubbly water. I think only the raisins are going to dance in the bubbly water because the experiment is called Dancing Raisins. So I'm only going to circle the raisins. That is my hypothesis or guess, is only the raisins will dance in our bubbly water. Now for the fun part, we're going to conduct our experiment. So get your bubbly water and let's try the pasta first. We're gonna put in 1, 2, 3, 4, maybe 5 pieces of pasta and see if it moves around. Well, definitely some of them are floating and some of them sink, which is interesting. I wonder why this one is floating and this one is just sinking. They're moving around a little bit. The bubbles are kind of just coming up right from the little pieces of pasta, but I wouldn't really call it dancing. We're gonna give it a minute to see if anything happens. I'm also curious to see if this one piece of pasta that's at the very top of my cup is going to eventually sink down like the rest of them. Yeah, not much movement from the pasta. The water is awfully bubbly though. It got so much more bubbly when I put the pasta in. See, all of my pasta is kind of floating like, well, one of them is floating, but the rest of them are lying down like a boat shape. I wonder what would happen if I dropped in a piece with this part facing down. It's just floating. Oh, it just sunk. I don't think it's going to dance. I think it's just going to make a whole bunch of bubbles, which is really cool. Let's test out our raisins next. The reason why I asked you to get a spoon or fork, in my case, is so we could gently take out the pieces of pasta. I have a little bit of a napkin here. So that way there is no pasta left in our bubbly water cup. And we can see how the raisins react to bubbly water. Here we go. So I got my pasta all out of my cup of bubbly water, and I'm going to add 5 raisins. Now make sure that the raisins aren't sticking together, because remember, they're very sticky, so they might want to stick together. Here goes. 1, 2, 3, 4, 5. Oh my goodness, so many bubbles. And we're going to wait to see if these raisins dance. That was our guess, our hypothesis is that the raisins will dance. Oh, there goes one. Did you see it float right up? You see how the raisins are moving around? Oh, it went back down. Are any of the other raisins going to float up? Let's see. Oh, there goes that one raisin again. Oh, and he went back down. Oh, he's standing up again. That one raisin is really, really moving around. And there he goes back again. Let's see if any of the other raisins will bob up and down or dance. If I kind of just move it a little bit to see if I can get some of its different sides showing. But I will say that one raisin, he certainly likes moving up and down. There we go. And you see how he's bobbing up and down? So one of our raisins danced. I have more raisins. I'm just going to toss them all in. Let's see what happens. Ooh. Do you guys hear the siren? That's the fire department in the town of Pittsford. No worries about the siren. So I have all my raisins inside here right now. Ooh, there goes one. He's dancing up at the top. So raisins totally do dance in bubbly water. I kind of knew that though, just because the whole experiment's called Dancing Raisins. You know what I don't know is whether or not beans are going to dance. So I'm going to take my raisins out using my fork. And we've got one more thing to test, which is our beans. And we're going to see if they move around in the water. Here we go. I did put a lot of raisins in it. All right, last raisin, you're out. No more raisins in my water. And it's time for the beans. Let's see what happens. I'm going to put 1, 2, 3. Wow, they sink right away. 4, 5. Oh, one of them was floating. 6. Actually, the little beans, they keep coming up and down too, just like the raisins. Did you see how they floated all to the top? I'll show you again. Watch how my little beans drop to the bottom when you put them in, and then they come right back up. That's interesting. Let's look closer at our beans. I wonder why that happened. Do you see how the beans are covered in little bubbles? Just like the raisins were. That's very interesting. So now we have to record our results. And in this very bottom rectangle that is green, we are going to circle the items that danced in the water, basically that moved up and down. And we're going to draw an X on the things that didn't move at all. So I'm going to draw a circle around those raisins. But I'm also going to draw a circle around my beans because they moved up and they're kind of shimmering around the top of my glass. But the pasta did not dance or move at all. So this is what mine looks like. All right. Now we're going to analyze our results. So our guess was that the raisins would dance because they were wrinkly. I kind of guessed the pasta would dance because I thought it would be wrinkly too, but I wasn't sure, so I didn't put it down. But believe it or not, the pasta did not dance, the raisins did, and the beans danced. That is very, very interesting. And our last step is we're going to report our results. So the conclusion I drew from our test experiment, and I'm going to share my results right now with you, is that it doesn't matter if it's wrinkly or smooth, it just depends more on how soft, because remember that the raisins were very soft and the beans had more of a softer texture, but the pasta was super, super hard. I think the softness matters more on whether or not something's going to dance in bubbly water versus whether or not it has wrinkles. But I'm going to go ahead and look it up and research. I wonder where a good place to research information about beans and raisins and bubbly water is. The library, exactly where I am. Well, I'm going to go and find a fun book about all of this. I hope you guys had fun. And if you guys want to read more about the scientific method, or maybe what makes seltzer water bubbly, or why lima beans and raisins are soft, come into the Pittsburgh Community Library and I'll help you find a book of another fun experiment next month.